Hello everyone, here is our Math Olympiad challenge which says square root of root 9 minus root 8. Today's Math Olympiad challenge looks impossible at first glance because of the square root of 8 that we have here. At first, it looks like an ordinary square root problem, but hidden inside it is a beautiful algebraic identity that most people completely miss. Now here's the question before us again, which says square root of root 9 minus root 8. The biggest mistake many people make while solving this question is immediately they see this question, they start calculating, saying square root of 9 minus square root of 8 will give us what? Square root of 1, which is totally incorrect. You can't solve Olympiad math challenge the way you solve your ordinary mathematics. In Math Olympiad challenges, the goal is not to calculate quickly, but to recognize patterns. So whenever you see several square roots inside another square root, that means there's usually a hidden identity waiting to be discovered. Instead of thinking like, how do I calculate this question? Ask yourself, can this expression be rewritten into something simpler? Then that mindset will make you to solve that question easy and faster. Now let's begin the calculation with the easiest part of simplifying the inner square root. Now inside this bigger square root, we have two inner square roots. We have square root of 9 and square root of 8. Square root of 9 will give us 3, but the square root of 8 is not a perfect number. However, root 8 will give us what? Root 4 times root 2. So root 4 is what? That is square root of 4, which is 2 times root 2. So square root of 8 will give us 2 root 2. Now let's write our expression, which becomes square root of 3 minus 2 root 2. Now we've been able to simplify the inner square root. The next thing now is, let's spot the hidden algebraic identity in this equation. Experienced Olympiad students immediately recognize 3 minus 2 root 2. Why? Because it looks very similar to the expansion of a minus b square. Now let's remember the algebraic identity formula, which says a minus b square equals what? A minus b times a minus b. Now a times a will give us a square. A times minus b minus b, minus b times a minus ab, minus b times minus b plus b square. A square minus ab will give us minus 2ab plus b square. The next thing is, let's choose a equals root 2 and b equals 1. Using our algebraic identity, that is a square minus 2ab plus b square. Let's substitute this into this, which will give us what? Square root of root 2 minus 2 times root 2 times 1 plus 1 square. Square root of 2 times square root of 2 will give us root 4 minus 2 times root 2 times 1 will give us root 2. So we have 2 root 2 plus 1 square, that is 1 times 1, 1. Now square root of 4 will give us 2. So we have 2 minus 2 root 2 plus 1. Let's rearrange. 2 plus 1 minus 2 root 2. 2 plus 1 will give us 3. So our expression becomes 3 minus 2 root 2. So this is exactly what we have inside the bigger square root. Now our expression becomes square root of a minus b square, which is square root of root 2 minus 1 square. Now remember that the square root of a square is the absolute value, since root 2 minus 1 is positive, then the square root simply removes the square. Now we have the square root of root 2 minus 1 square. So square cancel square root. So we are left with what? Root 2 minus 1. So without using the calculator, our final answer is root 2 minus 1. But if you are using a calculator, root 2 minus 1 will give us what? 0.4142. So either of the answer is correct. Without a calculator, you get this, and using a calculator, you will get this. Thank you for watching. Kindly like this video, subscribe to this channel, and don't forget to turn on your notifications for more math challenges.